Hello, and welcome to our lesson on the factor theorem. So in this lesson, we're going to understand what the factor theorem is and how we use it with polynomials. So if we look at the function of x in part A, this is x squared plus x minus 12. And we're going to find the factors of this quadratic, and these are x plus 4 and x minus 3. So these two factors multiply to make this quadratic. And if either factor was 0, then the entire quadratic would be equal to 0, because anything multiplied by 0 is 0. So if we make x plus 4 equal to 0, then x will have to equal negative 4. Or if we made x minus 3 equal to 0, then x will have to equal 3. So a factor theorem tells us that when f of negative 4, when x is negative 4, or when f of 3, when x is equal to 3, f of x will be equal to 0. So therefore, x plus 4 and x minus 3 are both factors of f of x. Okay, so we can use this idea to work out the factors of a cubic in part B. So to work out these factors, we're going to try some values of x. We'll begin with x is equal to 1, and we write this as f of 1. So now we're going to substitute the 1 in place of the x. So we have 1 cubed minus 2 lots of 1 squared minus a 1 plus a 2. And if we work this out, we get 1 minus 2 minus 1 plus 2, we get 0. So therefore, because f of 1 is equal to 0, x minus 1 is a factor. We can use the same idea when x is equal to 2. And this is written as f of 2. So we'll have 2 cubed minus 2 lots of 2 squared minus the 2 and plus the 2. We can work this out and we get 0. So because f of 2 is equal to 0, we know that x minus 2 is another factor. And because it's a cubic, we know it will have 3 factors. So we'll try x equals 3. Again, this is f of 3, which works out as 3 cubed minus 2 lots of 3 squared minus 3 plus the 2. 27 minus 18, take away 3 and add 2, is equal to 8. So therefore, because f of 3 does not equal 0, x minus 3 is not a factor. So now we'll try when x equals negative 1. So f of negative 1. We get negative 1 cubed minus 2 lots of negative 1 squared minus the negative 1 plus the 2. And this does work out as 0. So again, therefore, because f of negative 1 does equal 0, we know that x plus 1 is a factor. So finally, now we have our 3 factors, x minus 1, x minus 2, and x plus 1, we can write f of x as a product of these 3 factors. So x minus 1 multiplied by x minus 2 multiplied by x plus 1. Okay, let's try another question. So now we can use the factor theorem to see if x minus 1 is a factor of f of x, which is x cubed plus 4x squared plus x minus 6. And if it is a factor, then f of 1 will equal 0. So we'll substitute 1 into our cubic in place of x. We have 1 cubed plus 4 lots of 1 squared plus 1 minus 6. This is 1 plus 4 plus 1 take away 6, which is 0. So what we can say is x minus 1 is a factor because f of 1 is equal to 0. Do you want to try and work out whether x minus 2 or 2x plus 1 are factors of a cubics in questions B and C? You can pause the video and resume it when you're ready. Okay, for part B, so if x minus 2 is a factor, then f of 2 will equal 0. So we'll substitute 2 into our cubic. We have 2 cubed plus 6 lots of 2 squared plus 3 lots of 2 minus a 10. And this works out as 8 plus 24 plus 6 minus 10, which is 28. So therefore, x minus 2 is not a factor because f of 2 does not equal 0. And for question C, we need to make 2x plus 1 equal to 0. So x will equal negative 1/2. So when we have f of negative 1/2, we need to see if the cubic f of x will equal 0. So we'll substitute this negative half in place of x. So we get 2 lots of negative 1/2 cubed plus 5 lots of negative 1/2 squared minus 14 lots of negative 1/2 minus 8. So this is negative 1/4 plus 5/4 plus the 7 minus 8, which does equal 0. So again, we can say 2x plus 1 is a factor because f of negative 1/2 equals 0. Okay, let's try one more question. So here we have a typical exam style question using the factor theorem. So we've been given the function of x, which is x cubed minus 2x squared minus 11x plus 12, and we've been asked to show that x plus 3 is a factor of f of x, and then to express f of x as the product of 3 linear factors. Okay, do you want to try this question yourself? You can pause the video and resume it when you're ready. Okay, for part 1, if x plus 3 is a factor, then f of negative 3 will equal 0. So we'll substitute the negative 3 in place of x in our function. So we have negative 3 cubed minus 2 lots of negative 3 squared minus 11 lots of negative 3 plus 12. This is negative 27. Negative 3 squared is 9. 9 times 2 is 18. So minus 18. Negative 11 times negative 3 is positive 33. And then add 12. And this does make 0. So we know x plus 3 is a factor of f of x because f of negative 3 equals 0. And it's important to write down these statements when we do exam style questions. So for part 2, now we're going to express f of x as a product of 3 linear factors. And we'll do this using long algebraic division. So we'll have x plus 3 on the outside, and then we'll have our box with x cubed minus 2x squared minus 11x plus 12. So we'll begin by dividing x cubed by the x, and this will give us x squared. So now we'll multiply this through. We've got x cubed plus 3x squared. Then we'll work out the difference of our x squared terms, and negative 2 take away the 3 is going to be minus 5x squared. We'll drop down the next term, negative 11x, and then we'll divide the negative 5x squared by x. And this gives us negative 5x. So we'll repeat the process. Negative 5x times x is another negative 5x squared. And then negative 5x times 3 is negative 15x. The difference between the x terms, negative 11 take away negative 15 is 4x. We'll drop down our next term, and then we'll divide the 4x by x, which is 4. So finally, we'll multiply this out again. We have 4x and 12, and we can see the difference is 0. So we know x squared minus 5x plus 4 is a quadratic factor, and we can factorize this quadratic to make x minus 4 and x minus 1. So finally, we can now write f of x as a product of the three linear factors, and these are x plus 3, x minus 4, and x minus 1. Okay, thank you very much for watching, and I hope you found that useful. Thanks again, and take care.